Good afternoon and welcome to today's Adweek webinar. We'll be looking at the future of customer acquisition, and really it's why deep learning is your secret weapon in really getting you into a modern and effective customer acquisition program. And today's webinar is being sponsored by Cognitiv. I'm Stuart File, Vice President of Branded Content at Adweek, and I'm going to be your host for today's webinar. Before we begin, I'm just going to take a few minutes here and make sure that everyone knows what to expect from today's webinar, and also that everyone is familiar with the features of our webinar platform. Our presentation should go somewhere in the 30-minute range. Afterwards, we're going to have plenty of time for audience Q&A, and we know on topics like this we frequently get a lot of questions. So if at any point during the webinar, if you have a question for our speaker, just simply use the question tool that you see there on the left side of your screen to submit your questions, and we're going to get to as many audience questions as we can following our slide presentation today. So again, submit your questions. We will do our best to get to them. If we don't get to them, I always make sure they get forwarded over to our sponsor, so someone can always reply to you offline as well. It's not too late to invite your colleagues to come and join us today, and we'd really love it if you would invite them and if they could make it. Just to make it easier for you in this day and age of working in different places, we sent you a link in the reminder email we sent out about 15 minutes ago. So in there's a link to the registration page. Grab that link, send it off to your colleagues. There's still plenty of time for them to register, come on in and join us live. But if they can't make it live, today's webinar is being recorded and will be available on demand. And we're going to send you a link to that on-demand version at about 3:30 Eastern time this afternoon. So keep your eye out for that. If you would like a copy of today's slides, you can get a PDF of the slide deck at any time from the Event Resources area. That's a tab that you should see up at the top of your screen. So go on in there. Feel free to download the slides, share those with your colleagues, etc. I know a lot of people like to refer back to them just as a means of sort of staying on top of what you've learned today. Lastly, I just want to remind everyone to please check out the Adweek webinar calendar, www.adweek.com/webinars with an S. We've got a whole bunch of webinars coming up in the coming weeks, 3-4 a week. So see what's there. Probably got about another 9 or 10 posted on the calendar right now, and we're adding to it almost daily. So see what's there. Sign up for an upcoming webinar. You can also get full access to our archive of on-demand webinars. So that's every webinar that we've done over the past 12 months. If you go through that archive, you will find several from our sponsor today, Cognitiv. So I want to make sure that you keep an eye out for those as well. All right, let's take a second here and let me just introduce our speaker from Cognitiv. We are very happy again to be joined by Jeremy Fain. He's the CEO, also co-founder of Cognitiv, which offers really the first self-learning, fully automated neural network technology for marketers. Jeremy's got extensive background in interactive media, really across agency, publisher, ad tech. He had led North American accounts over at Rubicon Project, working there with some 400 plus media companies and 500 plus demand partners. He also worked at CBS Interactive in a leadership role, as well as at the IAB. So Jeremy's spoken with us before. I'm sure you're going to enjoy what he has to say today and get some really interesting insights. So Jeremy, let me pass this on over to you to begin our webinar today.
Great. Thanks, Stuart. Welcome, everybody. Thank you very much for taking the time to sit with us. And I hope that today we'll be able to come away with some new insights into some new technology that is really affecting sort of all parts of our lives and can really have a positive impact on your efforts from a marketing perspective. So today we're really going to talk about the challenges and complexities of customer acquisition as they are today, and then what this new technology called deep learning can do for those. So with that, I've been in this business for a long time, and the frustrations, frankly, they remain the same. Besides having less of a billing problem and things like that in digital media, we're still showing these same issues. Customer acquisition costs, they don't generally go down, they go up. A lot of the time they are greater than the lifetime value of the customer. We've got no scale beyond very generic third-party audience segments, and so getting the right targeting to get the results you need is very hard. Measuring the cost of the customer acquisition and really the lifetime value and all these other pieces, using the right KPI to proxy into profitability is very hard still. A lot of people are still using last touch attribution, which is really not helping figure out how much it's really costing and what the efficiency is of the acquisition. We have been trying manual optimization and some rudimentary AI optimization for decades now in digital, and none of them are really scaling past a certain plateau. And they're not consistent. Day to day, you have to try new things. That's not really what marketing is supposed to be, especially in digital. And then finally, a lot of the time it's very hard to figure out if one creative or another is going to work in that instant, right? The beauty of marketing is supposed to be the right message to the right person at the right time, the right place. And it's that right message in those other three things together that is the hope and dream of all marketers, right? And digital was really supposed to deliver on that, but it's been hard. It's not been easy to get to that point. A lot of people are using 5, 2, 6 different ad tech vendors to try to accomplish a number of these things discreetly, instead of looking at it as a complete and comprehensive optimization problem. All right, so if we have to use 5 or 6 different vendors now, can we use a single idea and a single sort of solution and technology to fix all of these problems? And today, really what I'm trying to show you today is how deep learning is helping solve all those problems and drive the future of this customer acquisition. So how is deep learning able to handle all of these problems? Well, deep learning has, and we'll get into this throughout the webinar, it has what we call adaptive algorithms. It creates and drives adaptive algorithms that can adapt on the fly, change on the fly, and really move as the consumers move, all right? And they're also built custom on first-party data of the marketer. So every marketer gets their own adaptive algorithm, their own brain that's running their marketing campaigns and choosing to solve that problem of the right message, right person, right time, right place, okay? It can do a lot of other things. So if you aren't ready for a full algorithm to drive your audience, to drive your advertising, you can create and use deep learning algorithms to create and scale and score audience segments, okay? Customized audience segments that are predictive to your prospecting needs, retargeting needs, etc. You can also use deep learning to infinitely experiment and hone in on and optimize on the right creatives. So which creatives should be shown at what time, in what place, to what person, in what order. Those are things that we're going to show you today deep learning is already able to do. Accurately measuring the cost of customer acquisition. We're going to talk a little bit about today, talking about how to do incremental CPA with deep learning, because that's really, if you take a look at it and you take a look at all the attribution opportunities out there, incremental CPA is really the cleanest and only thing that really can't be gamed for a marketer to take a look at how effective their marketing is. And we're going to really get into this deep learning thing. So next, what is deep learning and then we'll talk about how we deliver that from a marketing perspective. All right. So for those of you who aren't familiar with deep learning is a subset of machine learning, and machine learning is a subset of artificial intelligence. So AI is a very big and easy term to throw around. A lot of vendors have that. A lot of partners have that. A lot of agencies are working in AI. And there are a lot of different things that deep learning, machine learning, and AI can do. But the thing that sets deep learning apart from all other things, AI and machine learning, is that they're using this new technology, this new idea called artificial neural networks, okay? And they're called artificial neural networks because they're really designed to mimic the superpower of the human brain, which is our ability to generalize and do things. And that's why you see that deep learning is powering all these huge advancements in technology that we've seen over the last decade, okay? The idea that cars can self-drive, can drive themselves between the lanes, can understand what speed limit it is on the road after they pass a speed limit sign, that you can go into one of these Amazon Express stores and pick things out and not pay for them and just walk out, and then you'll be automatically charged. Siri and Alexa speaking to digital devices. All of those technologies, all of those advancements are being driven by deep learning. And the easiest way for me to describe the biggest difference between deep learning and the other machine learning that existed before deep learning was that before deep learning, you couldn't do any of those things. We've been trying to speak to our devices for years. We've been trying to use facial recognition for years. It was terrible and it didn't work effectively. But then deep learning came along, artificial neural networks came along, the technology and the process of training those neural networks came along, and all of a sudden the world has changed and made a huge leap forward from an artificial intelligence perspective. Okay, so self-driving cars, great. Talking to your device, great. But what is that? How is that going to help you with your customer acquisition costs and challenges? Well, I'm here to tell you that deep learning can deliver new customers at scale and help you retain your current customers, okay? So, for instance, we're going to have plenty of examples in here. Number one, like I said, you couldn't talk to your computer and cars couldn't drive themselves before deep learning, because the best we had before that was arguably logistic regression, which is an old data science technology, an old algorithmic technology that plateaus very quickly and has a limited sort of number of features that it can really use effectively. All right, but deep learning has an infinite number of features that it can use, and the more data you give it, the better it gets. That's why in self-driving cars, you see all these cars driving around with cameras and things, recording tons and tons and tons of footage about what a human driver is doing, a safe human driver is doing, so that the neural networks of the deep learning algorithm can learn how to mimic and generalize these situations. It's the same thing with Siri and Alexa and Google Assistant. They are listening to and transcribing tons and tons of human speech patterns to help those deep learning algorithms learn how to identify and understand human speech in all different languages. All right, so the more data you give deep learning, the better and better and better it gets. And that's a key part of how marketing can benefit, because all of us as marketers have more and more and more data over the years. All right, so what is a neural network? How does this all work? And why does more data make a difference? Okay, so from a marketer's perspective, you can have your own neural network by doing some very basic things. First, you have to have data to train the neural network on. And at Cognitiv, what we do is we have these easy plug-and-play solutions that generally are made up of, let's say, dropping a pixel on a conversion page, okay? But we also, from our clients, take in live ramp data files of their their best customers or certain kinds of customers they want more of. We also are going to show you a case study about footfall traffic based on location data that customers have on who comes into their stores, things like that. But you take this data, this first-party data, and you say, okay, these are the people we want to find more of, okay? We push it into a deep learning platform like Cognitiv Neural Mind, and it begins to build an artificial neural network, which is just this grouping of neurons and connections, okay? And then you start to train it and test it, and you give it that data, and it starts to create its own connections between all these neurons. All right, and the important thing about a neural network, and the thing that you see here is this is a very simplified neural network. It has basically 6 inputs at the top, 6 inputs on each layer, and then an output neuron, okay? But neural networks can be infinitely large. As long as you have the power of the computer behind it, you could have thousands of inputs. That's sort of what Cognitiv is using right now live, with thousands of different feature inputs, et cetera. And the interesting thing about this is that now, instead of saying, okay, males 18 to 34 works and everything else works really not as efficiently, we can say this time of day, this site, this person, this type of person works in this way with this message, but we get the same exact results with totally different set of inputs, which allows us to do what we call infinite clustering. We'll talk about that later. But the coolest part about neural networks and why we call them adaptive is that they learn on the fly. The more you train them, the more rounds they do, as we saw in that last graph. As the more rounds you do of training, the smarter it gets. That is exactly what happens. And the neural network is rewriting itself over time, rewriting its connections, rewriting the importance of the connections. And then finally, in the end, getting to a model that works really well in the situation that it is in. And then when it stops working well, it actually retrains itself to keep finding the best orientation. All right, so what does that mean for a marketer? Okay, we talked about scale and efficiency, plateauing, too much super targeting, et cetera. And really, this isn't how a deep learning algorithm works, an adaptive algorithm works, but it's the easiest way to talk about it for most marketers is we talk about these clusters, right? We talk about a demographic cluster or a behavioral cluster that you're targeting to try to find the most value in your advertising, the most efficiency. That's fine, but as we've shown, you have to get more and more targeted to get to lower your customer acquisition costs or your KPI, et cetera. But when you get more targeted, you lose the scale. So that's the biggest problem we have. Deep learning looks at it a different way. Yes, it can find clusters of people. Now this is a what we call a T-SNE plot of how we look at users in the marketing space. And this plot changes daily. As you'll see different plots in the rest of this call. But this is one version and view of a plot that shows all these orange dots clustered around closely. Those orange dots represent converters, okay? And so it makes sense that the black dots that aren't converting or haven't converted yet are highly likely to have something in common with the orange dots, and we're going to target those clusters. Piece of cake. That's like saying, okay, males 18 to 34 is our biggest customer. That's what we're going to do. Well, what about the other orange dots? Okay, there's tons of other orange dots spread out throughout this that aren't really clustered together. Well, deep learning can figure out what's going on with each one of those dots and discretely start targeting the black dots around each one of those dots to find that scale and efficiency, okay? And that's one of the big cool parts about how the adaptive algorithms work with an infinite sort of ability to take in different features and combinations. All right, does this work? Yes, it works. This is a footfall case study that we've used that we had at one of our clients driving store. This was pre-COVID, to be clear, because a lot of the footfall studies ended during COVID. They're picking up again now. But we found that we weren't even looking for incremental lift on this one. We were just trying to drive store visits, but we saw huge incremental lift. I think Placed was the third-party neutral measurement for this, drove millions of store visits on not that many impressions. It was a very successful campaign, and it was all really about trying to find the right people based on their behaviors to show them these 40 million ads. All right, so it works. Now, another way of looking at this is that it's adaptive, okay? And we're still going through this, but you know, our consumer behaviors changed drastically from before COVID to post-COVID. All right, and the algorithms see this. The deep learning capabilities and features that we're building have seen this, okay? So these are two of these plots before and after COVID, okay? And before COVID, I just wanted to show you sort of some clusters here that didn't exist really, had no conversions in them before COVID. And then all of a sudden, these sort of clusters lit up with a lot of new converters, okay? And that is the kind of thing that deep learning automatically can see, adjust to, and then move into those spaces, target those people, and find the right time and place and message to deliver better results without you having to guess, without you having to scratch your head and say, what's going to work now? Let's experiment with something new every day. Well, deep learning is able to do that automatically for you, okay? And how can this help you? Okay, well, another thing that we talked about, another thing that deep learning can do is that if you're not able to use a full algorithm solution, not a lot of the DSPs out there allow for an algorithmic solution. They have some programming capability, but you have to do it yourself. Well, you can use deep learning to at least help you find the right person to target and how much to pay for that person. So one of the things that Cognitiv has as a product is the ability to create large-scale custom audiences. We call them predictive audiences, and deliver those so that you can use them in your own DSP, but you have to solve for the right time, the right place, and the right message. But at least we can help you solve for the right person, get some efficiency in your targeting so that you're only targeting people that really have some propensity to buy the product that you're trying to sell. Right? And we've done this over and over. This is an example of using it for credit cards. They were, casting a very broad net, but not getting very good results. And it's a little small on this. But basically, the CPA that we were able to deliver on our segments was 64% lower, about 2/3 lower than theirs across 100 million user segments. So these are big segments, and they can be dynamically scored. Okay, that means that you can have deep learning segments that are high probability, medium probability, low probability. If your DSP or data solution allows you to upload scored users, so each user has a score, you can dynamically score every user. Not many data platforms allow for that right now, but we've worked with companies that do. And then if you have, let's say, 3 segments, you can pay more for the high probability and pay a lot less for the low probability, and average out your spend to something to help you lower, again, that CPA. So there's a lot of opportunity because of the scale that deep learning gives you in predictive capabilities, okay? Instead of having a hyper target, you can now target at scale. All right. So we've talked about the right person. We're not really going to talk about the right placement right now. It's just part of the adaptive algorithm and how it makes decisions. But another opportunity that deep learning can do for you is, because of its sort of infinite experimentation capabilities, is that it can find and hone in on which creative works for which person and which place at the right time. And again, this gets to this idea that you may be using a dynamic creative solution on one side, an ad server on another, a DSP on another, and then a DMP on another. And you have to put all those things together discreetly to try to optimize your problem, when really every impression should be optimized on all those levels at the same time, right? So once you get a programmatic request for a piece of inventory, you know where it is, you know when it is, and you know who it is. But now you have to choose which creative to show based on all those things at once. And deep learning can take care of that. It can also look at different states in the past. What did we show this person before? What are we going to show now? Where did we show that thing before? Okay, let's show something different now because we're in a different context. Okay, so creative optimization works here. And we've just got one very rudimentary slice of this for one of our big clients. And this just shows how the algorithms are choosing different creatives based on different sizes. And of course, creative optimization goes much deeper than this. With this, it's actually pretty hard to graph all those permutations. So one of the things we show here is that, you know, on the desktop, even by 728 versus 300 by 600, different creatives perform differently and work better. And the algorithm is choosing these things and figuring these things out. It's not being, no levers are being pulled by humans, all right? So we've gone over scale issues, we've gone over cost and efficiency issues, we've gone over the creative advertisement issues, and we're going to finish up with measurement, because measurement continues to be the biggest challenge of the industry, not only because Google, Facebook, and Amazon measure inside a walled garden and make up a very material part of a budget, but because even the stuff outside of that is still being measured by last touch attribution and KPIs like a straight CPA or a click-through conversion or something that seems simple and easy, but really isn't helping us understand and drive down our customer acquisition costs, drive up our lifetime value KPIs, okay? And the reality is, because CPA has been gamed for decades, all right? The reality is that if you're using last touch attribution, your vendors that are successful are most likely gaming the system by cookie bombing everybody and doing all these things that have been known to work for last touch attribution forever. It doesn't mean that those advertisements are actually contributing anything to a sale, okay? And people are moving forward, unfortunately, with CPA because it's easy and it's been done and that's what everybody knows. But the reality is, what you really want is an incremental CPA as your KPI, okay? And the incremental CPA is basically the cost of finding a true net new customer, okay? Brands have built brand loyalty so that people come back and buy over and over again. Those people generally don't need the same amount of advertising or any advertising at all, in fact, to come back again. You already have email to deal with that. You already have all these other things. But marketers are constantly just pushing advertising out there, regardless of whether it's a repeat customer, regardless of whether somebody's seen an ad on television and already made the decision. You need to change the game so that you're only spending on net new conversions instead of the ones that you've already won through other organic means. All right, and incremental CPA is not simple. Okay, and that's one of the reasons most people don't do it. But deep learning allows you to make it simple, right? So measuring incrementality, you have to have a scientific approach, and frankly, you have to have an A/B test. A lot of people talk about ghost ads because people don't want to spend 10% of their budget on PSAs. But the reality is, if you want to do this right across multiple vendors, you need to set aside 10% of your budget for a PSA. And that allows us to show a PSA to somebody who we think may or may not, we show the PSA to somebody, and then we see if they convert or not. That allows us to understand whether that person would have been an organic conversion or not. All right, but in deep learning, what we do is we do that. All right, we show these PSAs to 10% of the population randomly. We watch to see if they convert anyway. And then we say, okay, those people were going to convert anyway. They didn't need any more ads. All right, then we take, and that is the control group. All right, the experimental group is who the 90% of the ads go to, and see who converts there. Okay. Now, just because you saw an ad doesn't mean you're not, and you converted doesn't mean you weren't already going to be an organic converter. That's why we need both. Okay, we take those, we subtract them effectively from each other, and what we get is the leftovers. The leftovers are the net new converters. That's the incremental converters, okay? This is not easy to do unless you have a deep learning algorithm to figure it out, because the deep learning algorithm is going to generalize all these organic converters and try to avoid them like the plague. And it's going to generalize the experimental group and try to find them as much as possible. And then if you, for instance, very simplistically, run both of those neural networks and predict every impression using both of those neural networks, you can subtract them effectively and only buy inventory on what is highest probability of net new converters. So getting your incremental CPA to be extremely low. All right. And deep learning, in our opinion, is the only solution that's been able to solve this at scale. And we show it over and over, especially with big brands that are spending tons of money on television. For instance, this is one of the top, 5 insurance brands in the country. And every one of these 5 insurance brands spends a huge amount of money on television. And they want to only spend digital money on trying to find those people who have already not decided to like the Gecko or Flow or the Farmers Insurance Museum, etc., right? Or the Liberty Mutual ostrich or whatever that thing is. So AI, deep learning, can do this incrementality automatically at scale, all right? And it gets better over time. Let's go back to that idea that the more data you give it, the better off it goes. So with this client, in the first month, we were able to show 28% incremental lift. But years later, as we've kept this client going for longer and longer at higher and higher scale, the lift actually gets even better, okay? So from a small test to even more data at a higher scale, deep learning is able to deliver the learnings over time that nobody else can do consistently at scale. Consistently at scale. Those are the things that deep learning is best at. So if you're having problems with consistency or scale, and you're not using a deep learning solution, it's probably going to help you. All right. And then finally, we're going to end up talking just at a high level about retention. Okay. If you think about it, you get a customer, but then you have to hold on to that customer, to paraphrase Seinfeld. You want to take that customer and then upsell that customer, sell that customer new products, keep the customer coming back, make sure that they subscribe and never quit, on and on and on. All right. And every marketer has churn. Okay. Every marketer has tons of data on who's quitting, who's not coming back, how long it takes between purchases. All of these things are there, available. They may not be accessible, but they are available, and the ability to track them is there for all marketers. If you take that data and you dump it into a neural network in the right way and you engineer the features in the right way, you should be able to deliver a predictive, adaptive algorithm that can help you figure out which email to send at what time, to what person, what offers will work, experiment with offers and figure out which ones are better quickly for each person. And that's sort of going back to the creative optimization idea, is that it's not that this creative works the best. It's that each creative works the best for a different situation. Deep learning can do that with email marketing. Deep learning can do that for figuring out when somebody might quit, the probability of somebody dropping a subscription. When is that going to happen based on historical data of when it's happened in the past? So deep learning is able to better predict all of these things than any of the technologies that have been built before. So think about that also going forward. Today we really talked about media buying and media placement, but really the full funnel, including the loyalty cycle, is also right for deep learning opportunity. So to finish up, adaptive algorithmic advertising is a reality. It's giving the marketers that are using it an edge, and it's keeping their customer acquisition costs or their incremental CPA or whatever down while they scale up, okay? And that is, frankly, the first time it's ever been able to be done on a consistent basis. Deep learning is the thing that is enabling that. The adaptive ability of deep learning to, one, find infinite clusters, two, adapt to changing environments, creatives, treatments, taglines, etc., is the only technology out there that can do it. And it's a giant leap forward for AI. It's a giant leap forward for machine learning. And as hopefully you've seen today, it's a giant leap forward for marketers. And I would, highly recommend you talk to your vendors about what they're doing, your agencies about how they are using deep learning. Almost none of them are right now. And ask them and challenge them to investigate this technology a lot more. All right, with that, I'll hand it back over to Stuart for questions.
Thank you, Jeremy. Really interesting stuff. Always enjoy these and really understanding, again, where deep learning now intersects with acquisition and can start to show some real results. We're going to get to some audience questions in just a minute, a whole mess of them coming in now. So I do want to just remind our audience, if you do have a question for our speaker today, Jeremy Fain, the CEO of Cognitiv, just simply use the question tool that you see there on the left side of your screen to submit your questions. We're going to get to as many as we can over the next 10 minutes or so. If we don't get to your question, please rest assured I always forward all questions over to our sponsor. Someone will always see it and has the opportunity for an offline response as well. Some quick reminders before we get into the questions. First off, today's webinar has been recorded and will be available on demand. We're going to send you a link to that on-demand version about 3:30 today. If you've got colleagues who you think would be interested in this, feel free to share that link directly with them. Better yet, have them come on in and register. We will send them that link directly as well. So again, keep an eye out for the link to the recording. Also, if you want a copy of today's slides, a lot of information in there, things you might want to go back in and take a look at. A PDF of the slide deck is available right now in Event Resources. That's the tab up at the top of your screen. All right, Jeremy, let's get to some of these questions that are coming in fast and furious. And let's talk a little bit again, as you were looking at the end and showing again customer acquisition and incrementality. Can you give a sense here of why deep learning is so much better at that than sort of what your traditional DSPs are using for their machine learning and that segment on what they're currently doing?
Yeah, so I don't want to get into a lot of specifics about every DSP, but I would say this, that there are only a few DSPs that allow you to really bring your own algorithm, okay? And right now, as far as I understand it, that's really Media Math and Beeswax that just got bought by Freewheel. We have worked for a long time with Beeswax and think that their product for bringing your own algorithm is really good. From an incrementality perspective, if you're not using deep learning, you have to use something else. And the best that we've seen from other DSPs is generally a programmable bidder that gives you a number of different features, basically levers that you can pull up and down. But the other thing about it is it's a custom programming language, and it doesn't adhere to anything like logistic regression, let's say. Some of the DSPs we've seen have been experimenting with logistic regression, but on the other side of that, you have to have your own data science team to program that. So those are the biggest problems we see with the DSP landscape right now for marketers, is that the DSPs weren't built from the ground up to use deep learning. They weren't built from the ground up to be programmable, and sort of they're hacking things into it because some of the big agencies have data science teams that would like to experiment with this. But none of the agencies right now, as we've seen, have deep learning capability from a data science perspective. They don't have the ability to feature engineer correctly for those things. So there's a lot of barriers right now for marketers to get access to deep learning tools. One of the things we've done at Cognitiv because of all that is to make it plug and play, to make it easy, to make it so that you do not need a data science team that knows deep learning, because those resources are all inside Facebook, Google, and Amazon, trying to make as much money for those three companies as possible, regardless of what the marketer needs. So that's sort of where we are with that. And incrementality, just because it's such an advanced way of doing marketing, in that you have to try to predict who's going to be an organic converter. That's a very hard question, right? How do you know somebody's seen your television ad and is already predilected to do that? It seems almost impossible. What we've shown is that deep learning can do that prediction much more effectively than anything else out there. I'm not saying that we have anywhere close to 100% accuracy on that. We're talking about incremental improvement from 28 to 150%, but that's still not zero converters organic that we're advertising to. We're still advertising to plenty of organic converters that we probably didn't need to. But the efficiency boost compared to anything else is massive.
Yeah. A lot of questions. This question is sort of coming in a variety of different ways here, Jeremy. So let me see if I can sort of combine them all into a single question here. And of course, anything that is AI related is really, about feeding the beast, right? You have to have the data to go in to help everything to learn. So I guess the question often that comes in is, how much do you need to input here? How long does it take in a deep learning platform to sort of really start to get to these models? And, is there a break-off point where, you have too little? How do you ultimately sort of gauge that?
Yeah. So we tell prospective clients that we need at least 1,000 positive signals. So let's say 1,000 conversions. But really, if you have 10,000 conversions, it's even better. And it's really based on how long it takes for, let's say, the pixel to fire 1,000 times, or how recent 10,000 conversions are going to be for you. So we tend to focus on advertisers that are able to spend about $50,000 a month and have a decent conversion signal on a regular basis. That usually means that B2B marketers aren't really going to work well with deep learning, because the number of data points they have is just too low for deep learning. But 1,000 conversions to 10,000 conversions, I would say, is a medium-sized consumer business.
Mm-hmm. Got it. And that's what you're using to, again, start to trigger everything and build out the models as they go on.
We have success. We have success at Cognitiv with clients that are single product D2C to massive Fortune 100 advertisers.
Mm-hmm. Right, and it doesn't and it can be local, it can be national, it can be international. The key here is just having the volume of conversions as you go in.
Yes.
Definitely understood. Another question I'm sure you get on this because it's always on the top of everyone's mind, and that is privacy. So as you're doing this and you're sort of building out these models, what are you doing to sort of manage data privacy?
Well, none of the data privacy regulations is hindering any of this information, frankly, because we, as part of our contracts, we have to make sure that the advertisers themselves have access and are allowed to use this data. So whether that's under the California Protection Act or GDPR in general, data gathering for us is really on behalf of the advertiser, and they have to have the allowance to do that. So it's not really an issue.
And you're securing the first party data as well as part of this, right?
Yes, of course. We adhere to all the regulatory environments and all of those kinds of things.
Mm-hmm. Yeah. Interesting question came in here that I thought, as you're talking about incrementality and seeing those results on the campaign, right, it makes a lot of sense when you see that. But making the case for incrementality, especially, this is someone talking from a brand, right, where they seem to have plenty of budget for digital platforms. So, their sense is like, why test when we already have the money to spend? So how do you sort of go about making the case for incrementality, sort of proving them wrong that, that they should be testing instead of like, carpet bombing out there, just trying to sort of hit and identify sort of every possible group?
Yeah, look, incrementality is really more about incrementality in the sphere of algorithms and deep learning specifically is more about training data. It's really not a test. It's really about it is, in the end, it is a bad test, but you're testing the algorithm to see how good it is. But in doing so, you're teaching the algorithm that it's good or bad, and it will get better. That is a big part of why deep learning is so much better at everything from a computer perspective than the old machine learning, is because it learns on its own. So let's say that we have an incremental campaign going. Okay, we've already trained the models. All right. The reality of what we do once we've trained all the models is that we already have a model that we think is pretty good at identifying only net new customers. Okay, we actually randomly assign, let's say 10% or even 1%. It doesn't matter. 10% is better. We'll get a lot more data that way. But let's say 1 out of 10 of those people that come in that we think is a true incremental customer, we actually don't show them an ad. Okay, we show them the PSA, because if our algorithm is really good, showing that person the PSA means that they won't convert. All right. If they do convert, then we're not as good as we thought, right? And that result of whether they won't convert or will convert is fed back into the algorithm to say, you were right, you were wrong. And it adjusts itself all the time, constantly, over and over and over. And it just keeps getting better and better. That's why deep learning, PSAs, and all of that with incrementality is sort of the superpower of how to do this right. In the past, you were running an incrementality test, looking at the results and saying, well, it worked, it didn't work. And that was it. There was no feedback loop. Deep learning uses that PSA budget to get better and better and drive your incrementality down, from, in one instance, $150 to $10 at scale. That's the kind of thing that has not been consistently available to marketers ever before.
Yeah, it's the feedback loop that is that's the difference.
That's right.
Here.
You're constantly training with that feedback. Those PSAs are an important part of the training and feedback. Got
it. Jeremy, we are fast approaching the end of our time here, so I just want to take a moment and thank you for sharing that. As I'm doing that, of course, I'm going to put your contact information up here on the screen, so if anybody does need to reach out to you. And I do want to let our audience know again, if we did not get a chance to get to your question, I will forward it over to our sponsor. So someone can take a look at that, and hopefully someone can get back to you. So again, Jeremy, I want to thank you for sharing this and also taking some time and some questions. Just some final reminders to our audience. Again, if you want the slides, you'll find them in event resources. Check your email 3:30 today. We're going to send you that link to the on-demand version of today's webinar. And of course, adweek.com/webinars, our webinar calendar. Lots coming up. Good one tomorrow. Probably some of you are going to want to check out on commerce and data. As some of these things ultimately overlap, but see what's coming up. Sign up for an upcoming webinar or check out that archive of on-demand webinars as well. So again, I want to thank our sponsor, Cognitiv, and our speaker, Jeremy Fain, Cognitiv CEO. I want to thank our audience for taking time out of your busy day, and we look forward to seeing everyone at an upcoming Adweek webinar.
Thanks,